And I'm just going to introduce Krishan Bhatia from Energy Network Services. He's the president of Energy Network Services. He's an electrical industrial engineering degree and 30 plus years in lighting services. Energy Network Services operates Canada-wide. They're a first full-service lighting energy consumption management service company. They do lighting audits, design development, material evaluation, material procurement, incentive applications. They're not a manufacturer, and nor are they tied to any specific manufacturers or technologies, and their goal is to provide the best solution. Over to you, Steve.
Great. Thank you very much, JJ. So, I mean, obviously, you've got a few thoughts on this one. I always remember a specific statistic that, JJ, you taught me about redesigning lighting in a room, in a hospital room or a patient care room. So that's on slide 13. So JJ has got some good experience on lighting, as many of you do as well. So as we begin here, I always like to sort of start with the sort of the big picture view of this thing, and that when it comes to lighting systems, we're trying to find that balance between quality, cost, and energy. So ultimately, it's delivering a high quality environment when it comes to, you know, obviously the user of the space. We want to minimize the energy and minimize the cost, not just the upfront, but also the ongoing cost on lighting system. It turns out that in many energy systems, the upfront cost of equipment is minor compared to the ongoing cost of operating and even maintaining that equipment, but certainly for the energy. So life cycle costing, when it comes to any kind of energy system, goes a long way because it looks at the cost over time, not just those upfront costs, and certainly lighting fits into this category. There's really two ways to save in a lighting system, and I define a lighting system to be what I have on the right here, not the funny little character, but the idea that it's not just lights or lamps, it's not just a luminaire. It's in fact that luminaire in a room, right, or in an enclosure with a requirement, we call it the need here, and ceiling, walls, floors, all contributing to the proper or the appropriate direction of that light to the point of need. And then there's control, right, which we apply to it. So ultimately, we can reduce the wattage through you know, system efficiencies, and that doesn't just mean a new lamp. It can be in a new luminaire. It can mean changes to the reflectances of the walls and the ceilings in the room as well. The placement of the fixture and the overall system design. And then we can save energy by reducing the time. And then there's a controls aspect, but I'm going to come back to that behavior piece here, because lighting certainly is a place where behavior comes into play. We can control some things, but we can't control everything. And one thing that's important to keep in mind too, in the behavior side of it, once we start to take control away from people, we may get a backlash effect, and they don't pay attention in other places. So we have to be very careful that we don't disengage people from the whole idea of the role that they play by over controlling situations. Ultimately, I think what's key here is that you need to keep in mind, you always have a requirement, right? We've got to maintain and meet that requirement properly. We want to make sure that we take advantage of all the sources, and maybe daylighting is part of that. We also need to think about other things beyond light level, light color rendition, the impact on heating loads or cooling loads, and ultimately light pollution. You know, light pollution, I mean, it's probably not a big thing in a hospital, but clearly if we send light in directions that we don't want it, that's defined to be light pollution, and that's something we need to be cognizant of as well. Daylighting is good. I mean, it's good from so many different perspectives if we can use it properly. It has its challenges, but it definitely, natural light is always better than artificial light if it can be used properly. So in many areas are typically overlit, and we need to pay attention to those things. We do need to focus on the occupant and understand the impact that they can have, and also thinking about things like task lighting versus general lighting. So eliminating, you know, in my office here, I've got if I can show you here, I've got a 56 watt T5 that I put in 14 years ago. I never replaced it. Why? Because over here on the right hand side, I have a task light that basically that's what I use, right? And that's a 9 watt task light. So you can make a huge difference, right, by, you know, making sure that people have task light available. And task light's a good opportunity to give people very specific light as well. So we can start to address the human need aspect much more directly with task lighting. All right, play with my cameras. Light levels. How do we measure light levels? Well, how many people have a light meter? Probably many people have a light meter. It's important to use a light meter properly, measuring the light level on the right surfaces. It's also important to understand what the requirements are for light in different areas. And then things that a light meter can't measure, maybe the impact of different surfaces, things like that, although you can do a lot with a light meter. There's a neat little trick. If you have a light meter and you basically place, if I can get my camera here. So let's say I put this light meter towards a source of light, right? And it tells me a certain number of lux. And I turn it around and I point it towards the wall behind me and it tells me a certain amount of lux. I can determine by taking the ratio of those light levels what the reflectance of that wall is. It's surprising sometimes how low or high, and your eye kind of fools us at times when it comes to actually measuring that. And as I'll show later on, you know, reflectance can make a big difference to the performance of a room within a lighting system. Avoiding shadows is key, right? Because the efficacy of your lighting is going to come down to, you know, how good the human eye can operate. And speaking about the human eye, scotopic versus photopic, right? Your light meter may actually tell you something electronic, but it may not actually reflect truly what the human eye response is. So it's good to take into account the human eye response ultimately when measuring light as well. What light levels are needed?
That's how a lot of people will reduce their light level when going from high pressure sodium to LEDs.
That's right, because when you're going to a higher CRI lamp, right, you end up basically satisfying the needs of the human eye at a much lower illumination level, looking at it from the scotopic point of view. JJ, maybe you can speak to sort of the application of light levels or standards within hospitals, what light levels are really needed.
Yeah, we always go by the ESNA standard. So the Illumination Engineering Society of North America really applies good standards to light levels for different areas of a hospital. So does CSA now. They're getting involved in writing standards for lighting for healthcare facilities. You might have some other codes that come into play, such as fire code and that sort of thing. And sometimes I know on projects when it comes to lighting stairwells, and that's we've actually had local fire departments get involved in light levels there. Some facilities are looking at controls to lower light levels in stairwells that aren't used a lot with motion or occupancy sensing to bring light levels up when they are in use. Same thing with parking, garages, that sort of thing. So you get different local authorities involved in those types of projects.
Yeah, I actually skipped a slide I just wanted to touch on here. And I mean, many of you probably are aware of this, but the quantities that are used to measure light, obviously the amount of light that's emitted from a light source would be a lumen. And that's universal to both the metric and the imperial system. In fact, a foot candle is a lumen per square foot, and a lumen per square meter is then known as a lux, and the ratio between those two is the same as the ratio between a square foot and a square meter. And then the efficiency of a light source, we typically don't talk about it as efficiency, we talk about it as efficacy, because we have different units, top and bottom, so it's lumens per watt. So the watt in and the lumen out, that becomes the efficiency, and that's how we measure light efficiency, if we can call it that. I always tell people, if you cannot determine the efficacy of a light source, don't buy it.
Yeah.
Somebody's hiding something, right? So, so examples of different light levels that are required in different places, and they can vary a lot, right? I mean, these when I look at some of these light levels, I think this is pretty low, right? But then when you think about what's going on in these areas, maybe it's not as low as we might think. So
right. And, you know, typically, I think maybe on the next slide, it might show the common areas, corridors, and that sort of thing. Typically in healthcare facilities, when we do light level checks, we're finding that light levels in the corridors are listed there, 5 to 10 lux. We find that typically corridors, lobbies, stairwells are lit 2 to 3 times more than they really need to be. So, you know, if you want a good project, there's some place to start.
I think there's a typo in the slide. Does anybody see what the typo is? I'm going to.
I was going to say something, but I did not want to point it out.
Yeah. As many times as you check things, I know that we originally had 2 columns in this slide. One was foot candles and one was Lux. But I think the Lux title got attached to the foot candle column, right?
That's foot candles, yeah.
Yeah. We will modify that one.
I thought those places would be pretty dim. And by the way, JJ, when you find out overlit areas, very often it's due to having changed lamps from T12 to T8 and just doing a one-to-one change, and then going to LED, and all of those, including cleaning the lenses, ends up increasing the light level. Absolutely,
yeah. And that's something, you know, when you look at projects where you're replacing light fixtures, instead of going one to one, you might want to look at reducing the number of fixtures as another level of opportunity when it comes to a lighting project.
Yeah. And with LED, you have more flexibility because you can actually pick LEDs with various wattages. So you can adjust with keeping the same number of lamps, so that you have a proper distribution from your fixture. You keep the same number of lamps, but you make sure you pick the right wattage to get the light level you want.
Right.
And one thing I just want to reinforce is what's on the last point on this slide here is that too high or too low a light level is detrimental, right? I mean, we all think that too low is not good, but sometimes we think, okay, too high. But too high can be just as bad, especially in the presence of glare. When you've got even marginally high light levels and excessive glare, that can make a huge impact on the user of a space. And you know, the proper lighting goes a long way towards productivity and the proper execution of activities in that space. It can have a huge impact on productivity and wellness as well. We don't think about it as, I mean, we all think about indoor environmental quality as being indoor air quality, but light is part of that, a big part of that too.
We do have a question on lighting. What is considered a DEL premium? It seems utilities, especially in Quebec, Hydro-Quebec, are funding much more DEL premium.
I think that's LED, right? Well, that's it would be in French would be DEL, right? So
right.
So I guess the question, what is considered to be LED premium? Oh, that is, what is the, maybe Carl, can you open up your mic there and just elaborate that question a little bit?
Yes, I just had the call with Hydro-Quebec, or there was like a conference call about the new funding and the grants, and they always talk about premium DEL. So I just want to say, what is the criteria of LED, the premium LED? Is that ringing a bell?
No, I'm not familiar with Quebec, but typically the standard for lighting equipment is Energy Star rating or
the DLC, the design
or
light.
DLC, right? Yeah.
So maybe we can leave that one, or Michelle, you're in Quebec there. Do you have any thoughts on that one, or?
Well, I don't deal very often with Hydro-Quebec, so I know that they don't want to incent basic LEDs because it's becoming too mainstream. So you have to have a minimum efficacy for your lamp before you or you get more incentive. But to be honest, I was not sure what the premium threshold is, but it's probably very similar to what is done for other utilities, where you have to have either a type of rating, minimum rating for your lamp.
And this might be getting back to my point in the previous module where we talked about industry norm and incentives. So if LED and if Hydro-Quebec is considering the LED, the standard LED, the market norm now, they may have stopped paying out incentive towards that. And I think that we're going to see that in different areas or regions of the country.
Yeah, that's
what I do is reviewing programs for different utilities, and we have something called people that would install it anyway, and they get the incentive. So that actually has no benefit for the utility. those free riders. It's free ridership. And LED, for basic LEDs, the free ridership is getting to be quite large. And I can tell you, a lot of utilities will remove basic LEDs from their incentive program, and you'll have to pick what Cal mentioned, premium LEDs. That means they have to be Energy Star, they have to have a minimum rating.
Right.
Share at MUHC, the CUSUM building in Glen site in Montreal. We did like about 36,000 lamps, and the construction was it was only done in 2015, so we can recover the ballast. The typical ballast for the T8 can be used even with the LED lamps. So it was a really low cost measure with a lot of benefits on other stuff. So I don't know if maybe the premium is there should be a norm, or should be a threshold, or it's maybe that you cannot go back to the old T8 or T5 lamps with the actual ballast that you have. I know. So,
like Stephen said, DLC is usually the place to look for, and they do have a premium, and I think somebody might have put a link, but DLC
from AMO is just posted
a premium tag, and I think they actually upgraded. There's a 5, so Hydro-Québec could be referring to DLC, but I'm not sure 100%. Anyway,
it does appear to be DLC premium. Jeff from LAS has looked up some information, so it's a DLC premium, and it has a better light output than standard, and a longer life, of course.
Great. A couple of people have asked about downloading the presentation. We'll be providing those links after the sessions. So going beyond illumination level and efficiency, obviously color and color temperature are important things. As someone, I think, in a previous comment has pointed out, that there's, these things work interactively too. There's a big difference between even small levels like the 3500 and 4100 Kelvin light source. Certainly, we're today looking at many LEDs that are pushing into the 90s in terms of their color rendering index or color rendition index. Some people would refer to it as color accuracy. And I think that the standards certainly are growing. I mean, it's almost like, the lights that I started off with years ago, we wouldn't even think about those today. So the expectation of color rendition as being very high is good. And that's especially good in a hospital where you're dealing with sort of fine work, where being up, visual acuity is especially important. Even the difference, like you take a look on the little picture on the right-hand side, sort of a CRA 83 lamp, which is, I'd say, a typical fluorescent lamp, maybe, at 4200 Kelvin, very spotty spectrum, whereas daylight, which is sort of the gold standard, if I can call it that, at 5800 Kelvin, but a CRI of 99, much more representation of colors. So I think the key thing on this slide is to always ask questions about the light source that you're getting. Make sure you understand, the quality in terms of the color rendition, the color temperature, and small differences can make a big difference. Small differences in the numbers. Just saying over 90 is probably not sufficient today when it comes to getting a good color rendition index. One thing that Jeff mentioned in his text there about the premium lights is the life of the lamp too. And a lamp life, when it comes to LEDs, has changed a lot. How we specify them in the past, the lamp life was specified on the basis of the number of hours until 50% of the lamps in a certain group had failed. So you install 1,000 fluorescent lamps, and the lamp life was 20,000 hours. Well, what would happen if you would look at those 1,000 lamps? You would expect 50% of them to burn out by the time you hit 20,000 hours, and they would burn out within a pretty narrow range of those 20,000 hours. But when it comes to LEDs, because of the failure modes, we can't use that same measure for lamp life. So in fact, on this graph, we talk about an L70 life, and what that really comes down to is, as that dotted line shows, is that once the illumination, the light available from the particular lamp has diminished to 70% of its initial lumens, then that lamp is deemed to be at the end of its life, at the end of its useful life in that sense. So L70, the time to 70% of light output. So that makes a difference, right? Now, and LEDs tend to be a little more linear. You can see that T8 fluorescent that comes down to begin with and then goes flat. And eventually, once it hits its life, it'll drop off very quickly. They don't show that here. But with an LED, we tend to have a much more linear diminishment. And then the metal halides, which was one of the reasons that obviously there's so many improvements going from metal halide LEDs, is a very, very steep diminishment in light output, and then basically life of the lamp as well. But again, metal halides and fluorescents are rated to 50% of light, or 50% of them failing at the lamp specified lamp life, whereas LEDs, it's L70. And there are many factors that contribute. And even today with LEDs, we're not out of the woods when it comes to heat. Heat was always a factor when it came to fluorescent, and heat will still damage LEDs if they're not properly heat synced, or they're not allowed, or the fixture isn't allowed to be ventilated properly. So heat is still a very important factor when it comes to lighting today. Light source efficacy over the years have changed. Now this, I think this graph is a few years old, but I think what I would like you to take away from this graph is, even though on the bottom we have LEDs where we've got literally a whole range of efficacies from 20 to maybe 120 in the blue band, that's the luminaire, whereas our lamp efficacies could be in the 80 to 160, 170, 180. When you put that LED within a luminaire, you lose efficacy necessarily because of the way it's built. And I think that's key here, is that we have to make sure that we not only go to the most efficient source, but that we select and we use the luminaire. Even how we use that luminaire, the placement of the luminaire in the room, as you talked about earlier, JJ, can make a huge difference to the illumination level delivered.
Absolutely.
So, and this is my favorite slide, lamps and fixtures, and you talked about placement of fixtures, but you once told me that what you discovered in a patient care room, if you change the wall reflectance by 25%, you could reduce the lighting power to the room by 16%, right? And that wasn't by changing the color, it was just by the surface texture. But I think you discovered this because you were looking for paints that were more maintainable from a health perspective too.
That's right. It was a bit of a research project, and we took a matte finish. Architecturally, sometimes they like to work with different finishes. We took matte finishes off the wall, and it was the head walls of the patient room, and replaced it with just a painted surface, and definitely got much more lighting as a result.
Cool. I'm just watching our time here. Make sure.
And I just want to make a quick comment about color rendition. And in healthcare facilities, color rendition is definitely a very important aspect of lighting. You don't want to bring patients in and make a diagnosis based on patient color in a room that's lit with a yellowish glow. You want to have as a true light as you can when you're working with patients and making those diagnoses.
Yeah, so truly all aspects are important, not just the illumination level, the efficiency, the color temperature, and the color rendition index. Just even if we have the right color temperature, but we have a low CRI, we can end up with the same situation you just described.
Right.
When it comes to lighting design, there's a great reference here. I don't know how many people have seen this one before. It's called lightingdesignlab.com. And what it allows you to do is to look at sort of prototypical lighting layouts for various different scenarios. They've got parking garages, they've got open offices, they have hallway areas. There's many classrooms. I'm not sure if they have operating theaters, but basically there's a lot of really good information about sort of all these things combined in particular spaces. So these lighting layout guide series, and there's about 30 of them on the website. Definitely a good place to look for information. And it also references all the standards too in terms of the efficiency levels or the lighting intensity or density levels achieved. We talked, we got into the LED piece and we talked about the different kind of lamps. So this is kind of redundant. And clearly today, I think with little exception, that the strong migration to LED, the reason probably behind what Hydro-Quebec is doing, is saying we're only going to incent above a certain level, because obviously not all LEDs are created equal in terms of light intensities and performance, but also in terms of energy as well. So we want to make sure we move that bar up. And, you know, you talked about, I think there was some discussion about, you know, just replacing lamps within a fixture. You know, I would really encourage people to think about replacing fixtures as opposed to just installing lamp replacements. Certainly there might be some good opportunities with the lamp replacements, but depending on where that fixture is and in its life and the maintenance of that fixture, there may be even better opportunities for actually replacing the entire fixture as opposed to just replacing the lamps. JJ, you were going to say something there?
Yeah, and we have a couple slides further on that speak to some project work that had been done and comparing fixture replacement with lamp replacement. Lamps, definitely you get a great payback, as the slide shows here, 0.6 years or less with incentive. Fixtures, we're now, you know, coming to the point now where fixtures are lower in cost. And so we're realizing paybacks less than a year, except on pole lighting. You still have a little bit of an extended payback there, but nowhere near what it was 10 years ago.
But I would never do a lamp replacement in a pole fixture.
No.
So I think I skipped a slide here. There we go. Lighting system installation, right? So again, this comes back to looking at, you know, and maybe if you end up rewiring an entire fixture in order to do controls, then that kind of mitigates for replacement of the fixture itself. Certainly, when we do upgrades to lighting, there's an opportunity to upgrade controls at that point. And I know there's a few people out there have done quite a bit and are doing quite a bit in this area. There's some huge opportunities in adding control and being able to not just have an entire floor, entire room, but within a room and within large areas.
Yeah.
So there's a lot of trade-offs. I think the case studies do a good job of speaking to this one, JJ. So.
Absolutely. And Christian Badia is with us from ENS, and I just had a couple of comments, and maybe he can comment on them. But I was just going to say to everyone, you know, if you're going to look at a lighting project, don't jump into a big lighting project before you sampling a few fixtures first, because it just seems that the you know, lighting, you need to have the audience kind of test your product first. So install some lighting in a room, let staff within the facility have a crack at getting used to that lighting and letting you know what works and what doesn't. And also, I just want to emphasize that not all fixtures are compatible with all controls. And a great example of that is a lighting project we did in a long-term care facility. And new light fixtures and new dimmer switches were installed. But when the dimmer switches were dimmed down, it actually caused strobing in the light fixture. So you need to know that the fixtures and the controls are compatible.
That's a really common challenge these days. And even though there's sort of declared compatibilities between these things, there's a huge opportunity or huge gaps in that, right? So test, right. Just like in real estate, location, and test.
Exactly.
Test, right?
Yeah. This is Christian. I just wanted to inject in to say on the long-term care, we have had good experience. We've done almost 300 long-term care facilities. And recently, the ministry has been cracking onto the long-term care. Specifically, the light levels are not being met there. And the new light level come. And the most important factor which is being enforced is fail-safe prevention. They want to make sure that there's enough light at the night time when people get up. And there's some kind of under the bed lighting or some lighting coming from the washroom area, which can allow them with the help of a sensor. We have installed that kind of lighting, and that is becoming the demand day by day. They want fail safe for the people staying in long-term care or in the retirement home. So we have to start incorporating those factors in our lighting design in the hospital environment.
Right. Good point.
Yeah, I think that's, I mean, what you've just said there, Christian, is sort of something I've always said. I mean, if I didn't say already today, is and it kind of comes back to look for the least efficient or the unreliable systems, but look for a way to improve the lighting, and you may just find a way to save some energy. So thinking about all the things, so the safety, you know, the levels, you know, all of those things, put those first, and the solution you end up at, I think what you're saying, will be more efficient too, on top of that. And now you've solved a number of different challenges.
Yes. In point of the control, the new items which are being introduced in hospitals and the long-term care is kind of a radio frequency identification tags for the patients, which integrates with the lighting, and it can send a signal to the nurse's station if somebody gets up and falls while even sleeping, turning around. And so those kind of other factors can be incorporated into lighting, where the motion itself gets the report directly to the nurse's station that somebody has fallen from the bed with the sound or with the light. So those are things we are seeing in demand right now. People are demanding those kind of solutions, and there are solutions available.
Yeah, there's some great technologies out there, no doubt about it.
And since I don't know how much is time, I would like to also mention something about the UVC. Under the present COVID crisis, virus crisis, there has been new lighting LED site developed, which in the safe light wavelength zone around 365 nanometer to 405 nanometer, where the lighting can assist in killing the germs without harming the human eye or human body.
Yeah.
So those are the new lighting technology one could consider in improving the environment as well the health factors in the long-term care and the hospitals. And they come in two different intensity. At nighttime, they can be used in surgical areas where you can put the lights on for 8 hours, and all instruments, anything can be totally sanitized. So there's another new technology which has come in where your air can pass through over the light fixture and allow you to improve the germ controls in the facility. So I would suggest those kind of a technology also should be taken into account while selecting the products or doing any renovation projects in the hospital environment. And long-term care, those are very, very beneficial, and lighting technology has made stride into that market right now to assist the present crisis.
So again, it's the whole idea here is that set the energy aside and go after actually just improving things from so many different perspectives.
Yeah.
And you'll probably end up with those energy savings to boot, and a longer lived lighting system too. So.
Yeah.
Krishan, is there a way that you can share some of this information about new lighting technology with?
Yes,
with
certainly.
everyone?
I can send you some links.
Yeah, if you have some links, we can send that on to the participants and make sure that everybody has access to them. Yeah.
Yeah, certainly. I've got 4 or 5 different manufacturers. We are mostly North American manufacturer, good quality. And I can send a link to JJ, and then JJ can share them with everybody there.
Yep, sounds good. Thank you.
Yeah.
We're good. We've got a couple minutes left here. Maybe you'd like to just quickly tell us about the 3 case studies at the end here.
Yeah, just some case studies here. Edgewater Gardens, it's located in southern Ontario. We did a mix of lamp and fixture replacement there. Total cost of the project was about just under 22,000. Savings was estimated at just over 30,000 a year, with an incentive of 9,400 going towards the project. So payback with incentive was 0.4 years, and the modified internal rate of return. And this is what the financial people love to see if you're building a business case. You take inflation at 4%, discount at 3%, for an example, over 10 years. The rate of return is 42.5%.
Yeah, so this is why I like to amplify 0.4 years. Yeah, that sounds pretty good. But I mean, how many people have investment opportunities conservatively at 42.5%?
Yeah.
And Christian has asked how long ago the project was done. This project was done within the last 2 years.
And they were going to LED for the most part, right? Correct?
For the most part, yes.
Yeah, we have had experience in doing a lot of LED projects in long-term care in hospitals, and we have been able to get up to 2 to 2.5 years kind of paybacks.
Mhm.
And right now, we're currently doing a very large project in Hotel Dieu in Windsor, which is almost $200,000 incentive, and it's about 1.8 years payback. It's almost $1.8 million project.
Yeah.
So those kind of possibilities are there.
Good sized project.
Yeah, it's a good sized project, and we find they are very, very beneficial. And most of the time, we got to incorporate a factor called total cost of ownership. We always forget that lighting technology today, LED, is totally different than what our earlier lighting technology was. Total cost of ownership is related to the life of the lighting technology. If we are moving to the new lighting fixtures, you're looking at 100,000 hour plus life, which is based on even the areas like nurses and all, which is 24 hours on, or you can still get 10, 12 years out of that, 12 years life, which reduces your maintenance cost and your total energy cost plus maintenance cost. You take those into account, your paybacks are very, very short. So those factors, asset managers and the business case need to include that how much you're going to save on the maintenance side by incorporating this technology, which most of the time we forget. We don't include that. And we are looking at a simple payback or IRR. But this factor really helps to make a business case to the CFO that how much we are going to save on the maintenance side in next 10 to 12 years period.
Right.
And today's manufacturers are giving almost 10 years warranty on the fixtures. Some good manufacturers, 5 years minimum, but you can demand 10, you'll get it 10. So that kind of possibilities are there for all the managers in the hospital to take advantage and reduce the cost there.
Yeah, that's something I want to reinforce what you said there, Krishan. I mean, yeah, certainly, you can amplify when you go to internal rate of return, but I actually on my first slide talked about the fact that equipment costs more to operate and maintain than it does to purchase over the long term. So the total cost of ownership or the life cycle costs, I think, are a very powerful way to present these business cases, and it's certainly a way that most CFOs or financial people would certainly not reject, because it actually puts it into their terminology. So I want to reinforce that. And what we'll probably do is we'll make available a couple of tools at the end of the section for doing that. And actually, I've got a life cycle costing tool that we've used in other situations, and I might set up an example for lighting and just show how those maintenance costs really add up on the conventional source versus the LEDs. So thank you for making that.
We're getting on to lunch, so maybe we'll go through the next couple of slides and
So that's Winnebago.
yes, yeah.
And then we had the final one. This is, I guess it's at the same facility, a different retrofit, right?
Yeah, they're both dealing with Winnebago Area Health Authority.
Okay. Have you changed the slide, Stephen? It hasn't changed on my screen.
Oh, I'm sorry. Yeah. I was bringing, okay, there we go. Sorry.
Okay, so just a note here, these projects, I'll go through this quickly. Winnebago Area Health Authority is located along the west coast of James Bay. So getting fixtures up there was rather costly, but even with the high cost of getting the fixtures up there and getting them installed, you can see that we still had a very good, attractive payback on the project. So the first one was fixture replacement in one of the facilities, including exterior pole lighting and interior lighting. Total cost of the project was just over $85,000. Annual savings just over 22. Incentive was around 16,000. So simple payback with incentive was about 3.1 years, and return on investment with incentive worked out to be about 31.95%. So we go to the next one there, Stephen. And in another facility, relamping versus fixture replacement, lamping replacement done, and it was totally soft costs on labor because staff and facility took on the project. Total cost of the project around $61,500. Annual savings $70,500 a year. Incentive was $25,135. So when you look at simple payback with incentive, we're looking at 0.52 years. And return on investment with incentive, you're looking at 193.8%. So these are the easy ones to sell to your VPs of finance and your CEO. So with that, let's break for lunch. If everybody can come back at 1 o'clock, is it okay to do that? I hope. And we'll get on with the next module, which will be on commissioning and recommissioning.
AJ, I'm just going to leave the platform open so we don't have to have everybody reconnecting. If you want to just come back, that's fine, but I'll just leave it open. I'll take it. I'll be back here.
Sounds good. And thanks for Krishan for joining us and sharing information with us. And if you send me those links, I'll share.
A pleasure always. Anybody can reach me. You've got my contact detail, and I'll send you those links for the new products.
Yep, sounds good. Thank you.
Thank you. Thank you. Thank you, everyone.
Rob Kerrigan has posted links to a couple of videos on human-centric lighting, so some new ideas as well in terms of the quality of the light and with or without natural light. Correct, Rob?
That's correct, Stephen. Yeah, one of them's the videos about human-centric lighting in an office complex where you have windows, so it helps people work better. So it affects their, it links in with a circadian rhythm, and this human-centric lighting for patients also, they believe, can speed and aid recovery by getting their body on the right rhythm through lighting.
Excellent. We'll capture all these chats, and we can actually create a transcript from this too, JJ. So we'll do our best to send out, so that way if you didn't capture some of these things in the chat, you can always go back to it later as well.
Oh, that sounds good. Thanks. All right, so we'll see everybody at 1 o'clock.
Thanks so much.
Thank you. Okay.